Today we're going to talk about how a camera measures light and why some of the numbers on cameras don't really seem to make any sense. We'll talk a little bit about why the numbers are the way they are and why each component kind of measures things differently, and how in the end it all comes out to be about the same and it all comes out to be a very useful system. First thing I want to talk about is all the stuff we are going to discuss today. When we think of the numbers we have control over on a camera, let's just go from outside to in. We have the original source of light, right? Whatever we're actually taking a picture of. Then we have a lens, right? We have our lens, right? Although in our cameras it's going to be in a little box with a bunch of, other elements. And in there, in that lens is going to be an aperture. In that lens is going to be an aperture. The aperture is not at the end of the lens, but we won't worry about that right now. Then what we have next is a shutter. And this is the plate that comes down very quickly, first curtain, second and then second curtain, to give us the amount of time that the sensor is exposed to light. Then we have our sensor with all of its fancy pixels. And our sensor, it's right there. So we have light that is coming through. We have our light source. Let's do our traditional little light bulb. Boop, 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 boop. Light bulb. So we have light coming through here. Some of that is going to get grabbed by the aperture. And then as we get through here, some of it is going to depend. How many photons are let through is depending on how open this shutter is, or how long this shutter is open. And then last off, the sensitivity of the sensor determines how much each one of these photons sets off an actual reading. So the values we use for these, we don't really have a value for this within our camera. You can get light meters that tell you how much light a certain scene is giving off. We usually don't have that. And then the last thing I should say is your final picture, right? Final picture of our beautiful sunset. How light or dark is that actual image compared to what we saw over here? So the words we're going to use is this is an aperture, and the unit is f-stop. The shutter is simply shutter speed. Sometimes you will see this as the S mode on your camera or the T mode on your camera. If you want to control the aperture as your main control, you will generally see that as an A. The sensor is the sensor sensitivity. And that is done in a unit called ISO, which is an old unit that we still use. This generally doesn't have a mode on like the little dial on your camera. It is simply one of those things that you can set. That's ISO. On older film cameras, you also had ASA, but that is essentially no longer used in digital stuff. It's all just ISO now. Then this last thing is EV, or exposure value, and that is done in plus and minus. So you'll have plus or minus EV as one of the dials on your camera, on some cameras, or one of the sliders on a phone or something like that. So you will see all of these options on either a dial somewhere on your camera, on a slider, in a menu, something like that. The only one you will not see is this. You do not have a sensor dial for that. You control all these things and it gives you a plus or minus EV, or you hold these three and let this one float, or you hold these three and let this one float. However you do it, you're controlling three of them, and then one of them is moving to control the actual, or not to control, to give you the image you've asked for, right? So if I control all of these, but I haven't let enough light in, then my exposure is going to be very minus. It's going to be a very dark looking image, and we're not going to have any light in it. If I've left these on too long and I've let too many photons in, or I've bumped the sensitivity too high, then this EV will be very high. Or again, I can hold my EV and let one of these things float. So just be aware that even though it happens in this order, the way we can set automatic cameras is that we can set any of these values to float up and down and leave the other ones alone. So we have our aperture, which is going to be f-stop. We have our shutter, which is just the shutter speed. We have our sensor sensitivity, which is generally referred to as ISO. And then we have our exposure comp at the end, or exposure value, and that is going to be a plus or minus EV. Now, let's talk about why the numbers are so silly. The numbers that we use don't really make a lot of sense because we don't use a linear scale. And this is going to change depending on which one of these things we use, right? A lens has numbers that go like 1, 1.4, 2, 2.8, 4, 5.6, 8, 11, 16, and then it goes 22 and 32. Now, this looks like just absolute nonsense, right? Those are just numbers I pulled out of my butt. But they're not. They are the scale, and I'll show you why we use those ones. Shutter speed is going to move generally in a doubling fashion. So you'll have, you'll have 1 over 30, but we actually don't see this. Even though it's 1/30th of a second, on your camera, it will just say 30, 60, then it usually goes 125, 250, 500. You can kind of see a pattern of doubling, 1,000, 2,000, and so on and so forth. Sensor sensitivity, generally the lowest number you'll have is 100. Some cameras go down to 50, but generally what you'll have is 100, and then it again doubles as you go up. 200, 400, 800, 1600, so on and so forth. So these move in doublings, these move in doublings. These don't look like they move in doublings, but each one of these jumps is a doubling. These ones are obviously doublings, these ones are not obviously doublings, but everything is doubling. Now, or halving, right? If you go the other way, you're halving. Now let's talk about why we use that as a scale. So, linear scales, let me get a straight edge. Boop. Linear scale, let me get another one just in case I screw that one up. There we go. We have a line. Now, let's say that every 100 ISO is 1 inch. Okay? So this is 0. This is everything being off. This is ISO 100. Okay, let's go up to ISO 200. ISO 200 is another inch. That's nice and easy, 200. This looks like it's going to be pretty good. Let's go to ISO 400. Let's go to ISO 800. That is 4 inches away. ISO 800 is right here. And then ISO 1600 is going to be somewhere out here. And we are going to go and do that in a minute. We can do the same thing with our apertures. Let's start with f1. There's no good reason to start with f1. This is fine as a scale. Starting at f1 isn't actually correct because you can go lower than it. And this is going to be a little bit opposite. So this is the f-stop, 1. And then we are going to actually have the amount of light. So this is going this way, we get more sensitivity, right? Here, up at this top one, when we go this way, we are going to get less sensitivity. We're going to get less light into our device. So we go 1 stop away here. We get to f1.4. We go another 1. And again, this amount is wrong. We go another 1. that is going to get us to F2, as I said before. We are going to go to our next one, which is going to be F2.8. And then we are going to go to our last one that fits on our page, which is going to be F4. Now you'll remember that we have, right, F4 is just right here. We have quite a few more of these to go. And this same thing works for shutter speed doublings and for anything else that doubles. Now let's talk a little bit, before I show you how silly this actually gets, let's talk about what's happening here. So this is not a linear scale. So a linear scale is these numbers, right? 100, 200, we could put a 300 in here, but we're not going to. We could put, 5, 6, 7, and 800. These numbers are linear, right? 800 is 8 times 100. But when you roll the little dial, it's not 8 clicks away from 100. It is 1, 2 clicks, 3 clicks, because generally our full stop clicks are doubling. So we would click, click, and that gives us the difference between 100 and 800. Now you say, well, 3 clicks, that doesn't make any sense. You're doing 100 to 800. You can't even multiply anything by that and get to that value. Aha, but you can. Because the way that normal numbers work is it's just, let's not use n. It's a constant times a value. Right? It's constant times a value. Now, this is a log scale, which means that this is a constant times a multiplier to our value's power. So for ISO, for instance, let's use our constant of 100, right? That's our starting value. We don't need to split that generally. Then we are going to multiply that by our multiplier, which in this case is 2. So if we go, so this here is 0. And 2 to the 0th power is 1. So we have 100 times 1 equals 100. Then if we go 100 times 2 to the second, or I'm sorry, 2 to the first, we get 100 times 2, and that gives us 200. Now we go 100 times 2 to the second, that gives us, I'm sorry, we shouldn't do that there. That gives us 100 times 4 equals 400. And then this last one, to get to 8, we go 100 times 2 to the third, right? 1 click, 2 clicks, 3 clicks. This is our click value right here. It's not our multiplier and it's not our constant. It's our exponent out here. So what we're going to do is 2 to the third power is 2 times 2 times 2, which is 8. So we do 100 times 8, and that gives us 800 ISO, nailing our number right there. So those clicks, those single stop clicks on the dial, are not moving us a linear amount. They are moving us that exponent amount. It's a logarithmic scale. So we are going our constant multiplied by our multiplier to our value's power. So when you click it 3 times, you're going your base times 2 to the third power. That's our 3 clicks, and we're out at 800. So that's why these numbers are the way they are. This is how those things are calculated. It is this thing right here that is giving it to us. It is the exponent that's happening in the f-stop. That's also happening, in our shutter speed as well. So now what I want to do is take you outside, and I'm just going to show you how silly this gets, especially when we go from like ISO 100 to 800. What happens when we actually get to the end, and why do we use this doubling scale for our clicks as opposed to using a linear scale for our clicks? We are outside to look at how ridiculous a linear scale would be and why just dealing with the doubling scale and not thinking about it is probably the best option. Here we have our 0, 100, 200, 400, 800. So it's the same piece of paper that was inside. I'm on a wider lens now. This is our trusty orange bucket. Seems a little silly now, but we will need that in a bit. So we're going up in our doubling scale. This is 800. This can here on center is ISO 1600. This one here is 3200. This one here, 6400. This one here, 12,800. This one here is 25,600. Keep going. Let's find our next one. This one is 52,600 is what I said. And we can see our bucket way over there in the distance. And now let's go find ISO 100,000. There we are. So here is ISO 100,000. If we were on a linear scale, you can see how far that orange bucket is. It's, about 85 feet from us if we started the difference between ISO 100 and 200 at 1 inch. Yeah, so doubling scales are serious. So yeah, even though it doesn't look like much in an image, it's really, really important to use these scales and not a linear scale. Okay, so now that we've seen how this and why this gets so silly, let's talk about the individual values and what they do for us and what kind of how they all work together. So we are going to start out here with our light, which remember, we cannot control that at all. We just get n units of light. We just have to kind of deal with that as we get it. Our lens is our first one. And now the thing is that the lens will never, well, that's not entirely true. The lens most of the time will not give us more light than n, right? Like when we multiply the amount of light we start with by whatever our lens is doing to that light, generally it's darker on this side than it is on this side, generally. There are some lenses that break that, but we're not going to talk about those. So, for a lens, the value that we use is f-stop, which again is the aperture. And the aperture is like the iris of your eye, where it is the size of the hole that light goes through. So a big hole, lots of light goes through. Small hole, not as much light goes through. It's a relatively simple concept. Now, those numbers are stupid, right? 1, 1.4... 1.4, 2, 2.8, 4, 5.6, 8, 16, there's 11 in there, 16, 22, and 32, yeah, 32. So these seem insane, right? These are not doublings in the way that the other ones are, and that's why I wanted to start with this, because it's the weirdest. What these are is, if you watch my other videos about the basics of my camera theory dump stuff, lenses have a millimeter focal length. Lenses have a millimeter focal length, which is where this thing comes in. An infinitely small point at infinity distance comes through the lens and is resolved down to a theoretically infinitely small point on the sensor. Wherever that happens, that determines this distance. So in a lens like this one, this is a 50 millimeter lens. So this value here is 50 millimeters. Now, if we want, I'm going to show you how this happens. If we want to determine these values, what we do is we take 50 millimeters. Hang on, let me do this. So we have this value divided by the diameter of this, the diameter of the aperture. So it's the lens length, I'm going to put that in quotes, divided by the diameter of the aperture. Diameter, aperture. So an f1 lens, let's just use 50 millimeters, 50 millimeter lens over, well, if it equals 1, right? If it equals f1, we know that this divisor has to be 50 millimeters. So that means that a 50 millimeter lens with a effectively 50 millimeter hole in it to let light in. It's not always actually exactly 50 millimeters, but it's effectively 50 millimeters. Please be aware that that's not actual. It changes depending on like the makeup of the lens. It can be bigger or smaller depending. Like, so if you pulled the aperture out, it could actually be a different size. To get to f1.4, well, that's going to be weird, right? 50 millimeter over x equals 1.4. Well, I actually have to get out a calculator and do that math. So I do 50 millimeters divided by 1.4, and that gives me a value of x equals 35.7. So if I have a lens that goes to f1.4, right, that's 1.4 right there. Sorry, it's a little fuzzy. That means that the aperture hole is 35 millimeters for a 50 millimeter lens. I go into this in a little bit more detail in my brain dump videos, but this should be good enough for now. Now, the reason that this, if you notice, 35.7 is not half of 50, right? Even though I said this was half, it's not half this value. But remember, this is the diameter, right? This is this amount right here. Now, so if we remember, light is going to come in on an area of our circle, not on the diameter of our circle, right? When we open up this hole, we're increasing the area of it. So what we do is this is pi r squared, right? So we go pi r squared equals the area. And then we can do out this math, right? Radius is just half of these two. We can do out this math, and what we will find is that the answers to these two equations, right? If I go pi times, what's half of 50 is 25 squared equals area. And then I can go pi, this is 15, 17.5, 17.85, 17.85 squared equals area. Let me do that math really quick. So this area here comes out to be about 1962, and this area down here for our smaller lens comes out to, or for a smaller aperture, comes out to be 1,000. These are not exact because I've made some approximations on the value of pi, and I don't think this math is exactly right. But yeah, but these are pretty close to being doubled for these two values because, again, it is the area that lets light in, not the diameter, right? If you put a bucket out in the rain, the area of the bucket determines how much water you get, not the diameter across it. So just do be aware that this is a doubling even though it doesn't look like it. We can do out this math for each one. Okay, let's look at shutter speed. So shutter speed is easier. We have, if we look at our sensor from the front, we have our sensor. We have two curtains. We have two little sets of stuff that go above it. Our first curtain is going to come down and cover the whole sensor. Then as the first curtain recedes, the second curtain is going to follow it, and it's going to make a slit and cut through the sensor. On slow shutter speeds, the first shutter will drop all the way, and then the second curtain will follow it. On some digital sensors, you use an electronic first curtain shutter, and then you use a physical shutter to close it, or you use a fully electronic fully electronic shutter, which is where you read out all the data just off the sensor itself. You don't need a physical shutter to close in front of it. And then you have global shutters, which is an electronic shutter that does not need to go top to bottom. It can just read out the whole sensor at exactly the same time, which is super cool. And that's what I'm waiting for to buy my next camera, is a global shutter sensor. So this is our shutter. It just is two big plates coming down. You could think about it kind of like, it's not like curtains coming together, because it doesn't come together. What it does, it would be as if you had both curtains over here. You use one curtain to cover, and then you take that away, and then you bring the other curtain across to cover it, so you get an even amount of light across the entire image. I think I talked more about that in the other video as well. Now, this is kind of weird because it's a time thing, so we don't have a value, right? We're just using our arbitrary value that we've kind of said that time is. So what I like to use as a middle point is 1/50th of a second. That's because it's approximately what you can handhold a 50mm lens and get a decent shot. Anything slower than that, you probably or maybe need a tripod. Anything faster than that, you're going to be pretty comfortable. So I like to use that as kind of my middle point. Now, you're not going to see that value on a camera. You're probably going to see 1/60th, so I'm fine using that as our center point as well. So we are going to use 1/60th as our center. And then, again, you do not see it as 1/60th of a second. You just see the value of 60 on your camera. Then what's going to happen is you go 30, 15, and then it actually comes out of doubling, and you start to get some odd values like this. And that will give you just, it's close to doubling, but it's not exact, right? Like this is giving you like weird thirds in here, and this is giving you a little bit less than a double, and that's giving you a little bit more than a double. Oftentimes you will also have half a second. Realize that these scales and these dials change from camera manufacturer to camera manufacturer. You can also set them differently. You can set them to be full stops, or you can set them to be third stops, which is where you have 3 steps in between each of these values. You can also set them to be half stops. I don't think anybody does quarter stops, but hey, somebody might. Now, as we go faster, one thing I should note is that this will go down and keep doubling, right? Once you get down to 1 over 1 is 1 second, right? Remember, this is this value under a 1. So this is 1 second. Now, these can keep getting bigger, right? You can shoot for 2 seconds, 4 seconds, 5 seconds, whatever. Most cameras will stop at 30 seconds, and then you will see a B. That B is bulb. What bulb means is that you just have to physically hold down the shutter, right? As long as you hold down the shutter, it's going to hold as long as you hold down the shutter button, it's going to hold the shutter open. As soon as you let go, it's going to close the shutter again. Some cameras have a push to open and then push to close, but most are the push and hold gives you bulb. Generally, if you're shooting anything over 30 seconds, you're probably doing something very specialized, and you know all the better ways to do this with, remotes and things like that. So do realize that B is not some sort of weird magic. It's not black hole or something like that. It simply means that your camera's not going to meter or count anything past 30. You're going to have to do it with a stopwatch or something like that and use the bulb mode. Now, we can also go faster than this value, right? We go 125, not exactly double, but close. We go 250, 500, 1,000, 2,000, 4,000. Most cameras top out right around here. Oops, sorry, that's not an arrow. Most cameras top out right around 4,000. Slightly nicer ones do 8,000, and then some cameras with their electronic shutters do 16,000. Now, that's not 16,000 seconds. Remember, that's this value under a 1, right? It's 1/16,000th of a second, which is very, very fast. So this is how long we open the gates for light to come through, right? This is how long we're opening the gates to let light come through. If we open it for 1 second, we might get 1 unit of light. If we open it for 2 seconds, we might get 2 units of light. If we open it for 1/30th of a second, we get 1/30th of a unit of light based on just how much ever light's coming in. So realize that these are doublings and halvings. That's why you see these numbers as opposed to some more linear scale as we discussed before. So this is going to go anything from 30 seconds in bulb down on the slow side all the way up to usually, as I said, 1/4000th or 1/8000th on the fast end. Some things going even faster than that. There are some values with shutter sync speed and things like that about the speed at which those curtains move together. That is way beyond the scope of this video, so we are not going to talk about it. Alright, so last on our second to last, we have our sensor. So our sensor is again ISO. ISO is just so we have ISO. ISO is just the sensitivity of each little pixel, right? How many photons does it take for this pixel to come up one value? Right? All these values are somewhere between 0 to 255, which we'll get into later. Don't worry about that scale yet. But how many photons does it take to do that? The more we bump our ISO, the less photons it requires to go one step on this chart, right? To go from 0 to 1 or 255 or 254 to 255. So realize that ISO is the sensitivity of that thing. So when you think of people, that are very sensitive to touch, right? How much touch does it take before you can feel that thing, right? The more you push, the more you feel it. But also if you're a very sensitive skin, right? If you touch a more sensitive part on your body versus a less sensitive part on your body, you can feel more. So by changing the ISO, we're changing the sensitivity, not how hard we're hitting the sensor. ISO generally starts at 100. Some cameras start at 200. Some cameras start at 50. I would say that probably nowadays, this is 60% of cameras have a base ISO of 100. I'm sorry, a starting ISO of 100. I would say maybe probably 35% of cameras start at 200, and I would say 5% of cameras start at 50. This is pretty rare nowadays because sensors are good enough where a base ISO of 100 is just fine. Again, we are going to double and halve. One thing is that a lot of cameras, whatever this value is, you can't go lower. There's actually you just can't go this direction, right? For the sensor to be on, it has to be at least this sensitive for whatever your base value is. And you might see that when you're going through the little dial on your camera, you might see either a dotted line, or you might see that these numbers are in black and then numbers that are smaller are in gray. Wherever you see that split, either the black gray or the dotted line, that means that the values less than that are fake. It's the camera faking that value, and you're going to have issues in your image by using that thing. So I would suggest just not using it at all. So if you see gray numbers on this scale, don't use them. If you see numbers on the left side of a dotted line, or on the high end on the right side of a dotted line, or gray numbers on the right side of on the right side of the scale, do not use those values, right? Do not use those values. Use the actual ISOs for your camera. The ideal ISO for your camera is not necessarily these lowest values, but for the purposes of this video, lower is going to be better. So we go 100, 200, 4, 8, 1600, 3200, 6400, 12800, 25,600, 52. Wait, what is this one? 51,200. Let's see if I can do the math quickly in my head. 51,200, and then let's do 102,400. So that's the scale to 100,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9 doublings, right? So it's 2 to the 9th, for that, right? We're doubling 9 times, assuming we don't have 50, that gives us a 10th one. Or we can't go higher, and that gives us more. Most cameras, again, are going to start at 1 to 200, and they're going to end, if you have a camera you bought this year, somewhere in these 3, most likely. Somewhere in these 3. If you have a camera that's maybe 5 to 10 years old, well, I should say 5 years old, you're probably looking at max values 6400 to 12800. If you're going 10 years old, you're probably looking at, these 2 values. So this is 10 years ago, these values are 5 years ago, and then this is now, and then specialist cameras that are specifically built to do low light stuff are going to have values 100,000 and higher. So just realize that that's what you're going to see most of the time. When you click through, you're again going to click whole stop jumps, or you're going to do that third stop, right? 1, 2, 3 stops, or half stop jumps between any of these values. And that's just how your camera has it set, or how your camera manufacturer has it set from the factory. Again, this is just the sensitivity of that sensor. You're increasing the sensitivity and making it so fewer photons will set off that sensor and move the value up. So, we've talked about lens as aperture, we have talked about shutter, we have talked about sensor moving up as ISO. Now, the EV is just the exposure value. It's how bright or dark the image looks, and generally the way you will see that on your camera is it will be a 0, 1, 2, 3, -1, -2, -3. So that's what you'll see on that dial. Some go bigger, some go less. Generally, this is in 1/3 stops. I don't think I've seen many or any that do single click. Generally, the clicks are 1/3 of a stop in either direction. So you will see values like 0, 0.3, 0.7, 1, 1.3, and so on and so forth, right? Approximate thirds as you go up and down. So these are in third values most of the time, but you will start at 0 and then go up and down. So 0 is what your camera thinks is the right amount of light for that image. Less is going to look dark. More is going to look bright. This is just kind of personal preference. Some people like to shoot with more light. I find that can blow out images sometimes. So I actually almost always, and that's just my camera and my preference, I shoot at -0.7. That's 2/3 of a stop negative. And I just find that keeps me from blowing out my highlights. But I also like my images to be like dark and rich, and I don't mind if there's a little bit of noise if I need to bring all those lights up, and we'll talk about that. But I don't mind if I have to bring that stuff up, and I don't mind that little bit of noise in order to make sure I don't have blown highlights, and I can get lots of rich, like dark goodness in that in the image. We have talked about all these values separately, but not really what they do together, and not really why you would just not crank them all through the sky. So, we have our bulb again, right? We have our bulb, our light. That is just the amount of light that comes in. The only way we can control that is if we, turn on more lights in the room, or use a flash, or, go outside on a brighter day, or wait till the sun's higher in the sky. Whatever, right? We can't really control that internally to our camera. Our aperture, our f-stop, right? We should just bang that thing open all the time, right? Get the most light in we can. So the values here, so if we have a value of 1.424, that's all I'm going to write. The lower this number is, the more light we're getting, right? The more light we can get in to start with, the best. The more open that aperture is, right? The bigger number under our millimeter value on top is going to give us more light coming into our camera. Every time we go up, we double the amount of light being let through. Every time we go down, we are halving the amount of light that goes through. So this is, again, a one-stop scale. When you hear me say stop, that means a doubling. Like one stop is one doubling or one halving each way. So the amount of light, right, is x. Generally, we can only reduce the amount of light with our aperture. So this would be x, divided by, if we had a very bright lens that had 1, maybe we only have to divide x by 1, right? That'd be super cool. We don't lose any light in the aperture. But generally, we're going to have to divide x by some very real having value. So if I shoot a lens at f1.4, I'm going to divide my initial amount of light by 2. Right? I'm cutting the amount of light in half that comes into that camera. If I shoot at f2, I have to divide the amount of light that's coming into the camera by 4. So you can see how quickly we start to reduce the amount of light. Now, the benefit of tightening down an aperture is that we get more stuff in focus. So you can see that as I bring my hand closer to this lens, it's going out of focus. If I open up this aperture even more, this will go out of focus even faster. If I close the aperture down real tight, it will keep more in focus. If you want to see more about this, please see my other video about the brain dump camera stuff. The advantage of a big open aperture, just more light. The disadvantage of it is more stuff is out of focus. Of course, sometimes that looks nice, and that's what you want. Next thing on our little sheet is our shutter. Again, we should, we should just leave this open for as long as possible, right? We should just take everything at 30 seconds. We should take everything at 30 seconds, and that'll be great because that lets a huge amount of light into our camera, and it's wonderful. Not so much, because things blur, right? So again, I said about 1/50th, around 1/50th, for a 50mm lens. For a 50mm lens is about hand holdable, right? You can hold that and take a decent picture without everything being blurry, assuming everything in your image is still. Now, if I want to take pictures of fast-moving objects, well, I got to go faster, right? I got to go down to, when I shoot sports, my minimum is generally 1/1000th, right? If I shoot fast-moving things, it's 1/1000th, and preferably I just crank it all the way or all the way fast or crank it down all the way fast to 1/8000th of a second, right? That's really fast. But I get almost no light in the camera. Right? So by going down this way, we get a lot more light, but our image is going to be much crisper because it's taking less time to take the image. I go this way, I get more light, but I get the chance of everything being blurry. So generally above this line, I want a tripod or something like that, and I want to make sure that I'm taking pictures of very still subjects. Our sensor. Sensor's another thing, right? Let's just crank this number up. Let's get this boy going. So we start way down here at 100, and then we can just go up. We can go up to 100,000 or more. We can just keep cranking that value. Well, of course it'd be wonderful if we could do that, but we can't. Because when we increase this value, when we go this way, we get noise. Now, noise is something I'm not going to get into. It's extremely complicated. I touch on it. I don't even touch on it fully in the other video that I do. It is a lot of science. But generally, this is that funk snow stuff you see in your image when you take pictures at night with your phone. If you take a picture outside during the day, it looks fine. If you take a picture in the dark, club or something like that, and you get this like snowy kind of texture to the image, or these really bright singular specks, either way, what you're seeing is noise. The more we increase this value, the more noise comes with it. So the lower we can get this, right? This is less noise. This is more noise. There was something similar to this back in film photography. We're not going to talk about that, but just be aware that there was something called grain that kind of worked similarly, which is weird, but whatever. But our sensors have noise, and when we increase our ISO, it increases the amount of noise. You can also have issues with dynamic range. Dynamic range, we're not going to talk about that here, but you can have issues with dynamic range. Most cameras' ideal dynamic range is actually not at their low value, and it's definitely not at their top value. What that often looks like, I don't know where my ISO went. Let me just do it on here. What that often looks like is you have dynamic range over here, you have ISO down here, you have your low value, your highest value, And then you generally have, 1, 2, 3 stops, somewhere around there, above your minimum. And your dynamic range is going to be highest there, and then it's going to fall off pretty fast towards your top. So your dynamic range is not necessarily at the bottom. Oftentimes it kicks up a little bit, right? I think the highest dynamic range on the camera that I have, which is the Sony a7S that you're seeing through here, I believe that value is at 1600, but I'd have to check just to make sure. But realize that the dynamic range, which is the ability to capture both light and dark at the same time, is not always at our lowest value. Sometimes it's a little bit higher. So just be aware that dynamic range and noise are separate, and they oftentimes do not have the same ideal point. Okay, then our exposure value, right? Our EV plus or minus. This one, again, it's not something we have control over. This is just going to make that picture a little bit brighter looking or a little bit dark looking. Now, realize that a doubling of light and a halving of light does not look like a doubling or halving of light to us. It looks just a little darker. It looks just a little brighter. I can actually set this. Right now I have this at a slightly positive exposure value because I'm shooting a piece of paper. Let me crank this down. 1, 2, 3. I'm sorry, that cranked up 3. So that's double. 1, 2, 3. And that's half. Now that doesn't look like half to anybody, does it? So realize that these doublings and halvings to our eyes just do not look like doublings and halvings. So like when you think of double, you think of like, oh, I'm going to have, 1 piece of pie or 2 pieces of pie or half a slice or half a pie or an entire pie, right? That's a hugely different amount. But for cameras and for our eyes, it's really not. Doublings looks pretty incremental to us. So just be aware. The amount of light we can get in, great. Then we can use our aperture to let more light in at the expense of things front and back being out of focus. We can make our shutter slower so we get more light by leaving our light buckets open for longer. Or we can go faster and get really sharp images with no motion blur. Our sensor, we can add noise to get more sensitivity, or we can reduce noise and go way, way low, but we're not as sensitive. And then dynamic range is somewhere in the middle. And then our exposure, plus and minus, is just how bright or dark you like your image to look versus what your camera thinks is a true neutral. So your guys' homework is going to be to explore these things on your camera. What I want you to do actually first, before you kind of do anything, play around with this EV plus minus and just figure out what looks good to you. This is going to change depending on what situation you're in, right? At night, you might want it different than you want during the day or during a bright day. But what I want you to do is just in a good neutral setting, like wherever you usually shoot, pick out what is your EV, right? EV 0 is what your camera shipped with. Is that right for you? Do you want a little bit more light? Do you want a little bit less light? What looks right to you? And I want you to find that, and you're going to tell me what that is, right? What is your exposure value that you like? Again, mine, -0.7, just seems to work out the best for me. Then what I want you to do is go through the remainder of these 3 things, right? The aperture, the shutter, the sensor, right? The ISO, the shutter speed, and the f-stop. And what I want you to do is explore the top and bottom end of each of these values, and then one in the middle. So for aperture, let's say your lens goes from 4 to 22. I want you to do one picture at 4, one picture at 22, if that's the most closed, and then one at whatever the middle is, which I think is, 11? Something like that. Then for shutter speed, I want you to do the same thing. I want to see a picture at 30 seconds. I want to see a picture at whatever the fastest your camera can do. And then I want to see a picture at that handheld value, right? Whatever your handheld value is, again, I like around 1/50th of a second. So that's 3 pictures here, 3 pictures here. Same thing with noise, right? And I'm sorry, sensor sensitivity, which will have different noise look. What I want you to do is shoot at your minimum, not the gray minimum, the first one that looks like a real value. One at the top, and then one at whatever the middle of that chart is. So just write them all out, right? If your ISO only goes from 100 to 800, well, that's okay. Or let's go to 1600. So let's say your camera only has those values, right? That means I want you to take a picture at ISO 100, and I want you to take a picture at ISO 1600, and then I want you to strike the middle and give me another picture at ISO 400. Now, to get this to work, you're going to have to shoot in different amounts of light. You're also going to have to adjust the other things to make these happen. So you might have an image that is your fully closed aperture at a max shutter speed and at a max ISO or something like that, right? So this doesn't necessarily need to be 9 images. I think 9 images would probably be best. More practice is always good. But you can actually combine these things together, and I'll let you figure out exactly how to do that. But you can combine these things together, and actually you could get away with only taking 3 pictures if you really wanted to. But I don't think you should do that. I think you should shoot for 9. Really explore the minimum, maximum, and middle values on all of these things. And I think that you're going to have a much better understanding of what your camera is capable of, and more importantly, what your specific camera looks like when it's doing these things, right? My camera and your camera are going to look different when we do these things.